In this video, we're going to go over how to find all the zeros of a polynomial. So some polynomials are easy to type in your calculator and find all of your roots or zeros on the x-axis because those are your x-intercepts. So remember, the degree of a polynomial matches the number of zeros it will have when you're done finding all of them. Now, if it's not one that you can find all of your roots just by checking the graph, we need to have other methods. So this is what we're going to go over. So we need to use a given factor or root, which was listed as step 2 right there. So that's if it's not just something we could type in the calculator. We're going to use that to divide the polynomial using synthetic division. And if the remaining polynomial is linear, then we're going to set it equal to 0 and finish solving. And if the remaining polynomial is quadratic, we're going to use the quadratic formula or square root method to finish solving. And then we just need to list all of our zeros together and make sure we have the right number of zeros at the end. Okay, so we're going to go over two good examples of this. Example 1 is f of x equals x cubed plus x squared minus 7x minus 3. They told us x plus 3 is a factor of this polynomial. So therefore, we know that if we say x plus 3 equals 0, then x equals negative 3 is a root. We're going to use the root to reduce the polynomial using synthetic division as our next step. So put your root in the little box to the left. And then you want to list out your coefficients. So 1, 1, negative 7, negative 3 are the coefficients of our polynomial that we're going to reduce. And we're going to use synthetic division. So we would drop down the 1. 1 times negative 3 is negative 3. We add those together, so 1 plus negative 3 is negative 2. Negative 2 times negative 3 is 6. Negative 7 plus 6 is negative 1. Negative 1 times negative 3 is positive 3. And then we should have no remainder because we were told that x plus 3 was a factor. So that's kind of a checkpoint in your problem to make sure you're doing things right so far. Okay, so then we need to add our variables back into our quotient. We need to put x squared because it's always one less power than what you started with in your original polynomial before you divided. So we have x squared minus 2x minus 1 is what we got for our reduced version of our polynomial. We reduced it using the factor they gave us. Now, if you notice what that looks like, it's quadratic. So we're going to use quadratic formula. So let's write x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and we're going to type in, we're going to plug in our a, which is 1, our b is negative 2, and our c is negative 1. We get that because standard quadratic form is ax squared plus bx plus c equals 0. Okay, so let's put that all into the quadratic formula carefully. So we need x equals negative b, so that's negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 2. All divided by 2 times a, which was 1. Now what I recommend is type in everything underneath that square root into your calculator and make your life easier. If I can pull up my calculator, let's see. So I'm just going to type that part of this problem into my calculator. So that would be just like it looks. So negative 2 squared in parentheses. The parentheses are very important because this is a negative that I'm squaring. So make sure to type just like you wrote it. Okay, so we should get 12. So we get x equals negative 2 turns into a positive 2 plus or minus the square root of 12 divided by 2 times 1, and that's just 2. Okay, so now we need to think about the square root of 12. 12 comes from 3 times 4. We need to make a factor tree. 4 comes from 2 times 2. So it's the square root. We can take out a number we have 2 of. So that means we could take out the 2, but we still have the square root of 3 left over. And now we just need to put all that together. So let's see. I'm going to write it over here. So we get x equals 2 plus or minus 2 square root 3 because we reduced the square root of 12. That's all I did for that step. And then it's still all divided by 2. And then in my last step, I can divide those front 3 terms if possible. So 2, 2, and 2 would all divide evenly by 2. And my final answer would be x equals 1 plus or minus the square root of 3. Okay. Now our final step is to list all the roots or zeros and how many should there be. So let's talk about that for just a second. If you look at the original polynomial that you were trying to find roots for, it has a degree of 3. It was written in standard form. It was descending order of exponents. So you had a 3, a 2, a 1, and then technically you had a 0 at the end. So it was descending order of exponents, and the highest power was 3. So that's your degree. And that equals the number of zeros we're looking for. So zeros are the same thing as roots and x-intercepts. So let's put it all together. They gave us x plus 3 was a factor. So remember in the very beginning of our problem, we said -3 is a root. We need to include that in our answer. So we say x equals -3, and it's also equal to what you got from solving the quadratic formula to get your 2 roots that just weren't as, like, they're not as nice even numbers as the -3. They're irrational numbers. And that's it. So we have 3 roots. Technically, we have x equals -3, and we have 1 plus the square root of 3, and we have 1 minus the square root of 3. It's okay to write it together or separately, but just notice that is 3 separate roots. Okay, so let's work on another example. So number 2, it says, how can we find a root of this polynomial? So just like in the directions we went over, we need to type it into Desmos, just like it looks. So x cubed minus x squared plus 2. And you've got to find your x-intercept. So it looks like -1 was the x-intercept, which is our root. And we can put that in our box and start our synthetic division. Okay, so I'm going to bring down my coefficients. I've got 1, -1, and 2. But notice I'm missing the x term, so I need to add a 0x in there to make it work out okay. So 1, -1, 0, and 2 are my coefficients. We drop down the 1. We say 1 times -1 is -1 and put it under the next number. Then we add those together. So we get -2. -2 times -1 is +2. Then we add those together and we get 2 again. 2 times -1 is -2, and you should end up with no remainder. And you should end up with no remainder because you used a root. In other words, x plus 1 is a factor, and it should divide evenly. So that 0 right there is a checkpoint that you're doing things right so far. Then let's put in our variables in our quotient. So we started with x cubed. Our quotient starts with 1 less power. So we have x squared minus 2x plus 2. And from there, we can see that it is quadratic. And we need to pick out a, which is the 1, b, which is the -2, and c is 2. A, b, and c are always just numbers. They never include any x's. All right, and let's fill it into the quadratic formula. So you've already written that down in example 1, so you have it on your paper. I'm just going to fill it in and not take the time to rewrite the whole formula because you've got it on your paper already. So x equals -b, so -2, plus or minus the square root of b squared, so -2 squared, minus 4 times 1 times 2, because that's my a and my c value, all divided by 2 times a, which is 1. Make sure that fraction bar goes all the way underneath everything. And then we just need to clean it up. So x equals -2 turns into a +2 plus or minus the square root. And we want to type all of that into the calculator just like it looks. So type -2 squared in parentheses. If you don't use parentheses, you will get a different number because it was a negative that was squared. So that is a very important step in this process. Okay, so we get -4 underneath the square root. And then 2 times 1 is just 2 at the bottom. Now -4, we've got to simplify. So the square root of -4, we say is equal to the square root of -1 times the square root of 4. And in math, the square root of -1 is imaginary because it really doesn't exist. So we put a little I that's equivalent to the square root of -1. And then the square root of 4 is 2. And so what happens is the square root of -4 is just simply 2i. And we bring that back over and put it in our problem, and then we just need to reduce it a little bit further because the 3 leading coefficients of those terms can reduce. So we need to do that. So then we get x equals 1 plus or minus I, and then the 2 at the bottom would turn into a 1. So we just don't need to write that one down. And that is it. And you can tell from your graph that those would be imaginary because they never cross the x-axis. So it does make sense that 2 of your roots are imaginary and 1 was real. So we had x equals the -1 we found on our graph, and we have 1 plus or minus I for the other 2 roots. So remember, you can write those separately as 1 plus I and 1 minus I. So you can see all 3 of your roots. And we know we needed 3 roots because our degree in our original polynomial was equal to 3. And that should always go together. Your degree should match the number of roots that you find. Okay, so that's it for finding zeros of polynomials.